Welcome back, everyone. So continuing on with the database store, in this video, Nelson will be implementing the store new record, the overwrite existing record, and the append to record list. Now, these are going to be relying on other methods that we will just basically get stubbed out as we've been doing as we've worked our way through this database class here. And in the next video, we'll implement those methods.
Yes.
That's right.
Okay, so we'll start on StoreNewRecord, which is going to be pretty straightforward. Because remember, StoreNewRecord is the instance in which a record doesn't exist at these coordinates at all in the entire database. So it's probably going to be our simplest case. So first we need our record position, which is going to be our file stream.length. Basically, we're positioning the record at the end of our file stream. And then we're going to get to store, which is going to be get record data to store. And we're going to implement that later. And then we're going to say index set first record position at info coordinates for record position without an M. And then we're going to lock out our file stream and write a record, which is going to be record position. And then toStore actually returns a tuple, so it's going to be toStore item 1, toStore item 2, and we'll get to what those mean later. As you see, tuples, while incredibly awesomely useful, aren't very communicative about their intent, which is why I usually don't use them for public-facing members.
Right.
Okay, so that's StoreNewRecord, pretty straightforward. Now we have overwrite existing record, which has two cases in him. First of all, we need the data to store, so we're going to get record data to store by passing in our record and our info. Then we're going to say toStore.item1.next record equals existing header. Existing header, I just renamed the parameter from last header to existing header. If you remember, that's going to be the last header that was passed in. So the next record is going to be the existing header's next record. So basically, if you think about a linked list, we're overwriting a member in the middle. So we have to take the pointer of the previous guy and set him to the pointer of us, and then do the opposite and stuff. Mm-hmm. But unfortunately, we don't know what the position of our... Say something?
No, I was just going to say real quick, on line 102, go ahead and fix your get casing.
Yeah, when you type quickly, IntelliSense usually figures out your casing for you, but because we don't have it, I apologize.
It's all good, Nelson. All right, so continue.
So we need to do stuff. We have two cases, and one of those cases is the record data that we're going to be storing, is that bigger or smaller than the record that we're going to be replacing? And this is just a simple strategy to avoid some, but not much, fragmentation.
That's right.
So we're going to say if toStore.item2.length. By the way, item 1 is going to be the record header. So it's going to be the new record header that we're making for this record. Item 2 is going to be a byte array for the actual bytes of this record data that we're storing.
See, these things called comments would be very handy. And you don't have to put them in, but I'm just pointing out that if someone was just taking a look at this method, the names would not be very helpful there.
But once the types are there, they would be, because you'd be able to mouse over this and say, oh, item 1's record header. It was retrieved from get record data to store. Therefore, I can conclude that item 1 is the record header that we're supposed to store.
So basically, I have to interact with the code by moving my mouse around as opposed to just opening and reading. Continue. It's all good, Nelson. I'm just giving you a hard time.
So we have our existing header, length, or data size. So this is saying if what we're storing is larger than what we have there, we're going to have to do a bunch of nasty stuff. We're going to have to calculate a new position, which is going to be at the end of our file stream. We're going to have to write our record at this new position. And then we're going to have to set the index of this to our new position. So the index of the first record. I don't think that's right, but I'm just going to go with it. So next step is if our previous header, ph, existing header, sorry, is not null, so that means this isn't the first item in the list, or this isn't the first item in our record list. Actually, that's what I did wrong. We want to say if the existing record is null, then we want to set the first record position to this.
Okay, that makes sense.
For some reason, that's impossible. Don't tell me record header is a structure. No? How can existing header always be null? Or always not be null? Oh, because I already use existing header. I am severely confusing myself. And the reason I'm severely confusing myself is that I was an idiot. Yeah, I got these two record headers mixed up. See, this is the importance with names. I just want to point that out, because when you have poor names, things start to confuse you, and then you don't know what you're doing, because obviously these are two record headers. One of them is what we're working with right now. The other one is the previous record header. This is what we're going to be calling the existing record header. This is going to be what we're calling the last header. And this is the existing header. Okay, so now that makes sense, right? If the existing header data size, existing header being the header that we're saving, hold on, last header, do we use this guy erroneously elsewhere? Yes, we do. Okay, there we go. So now this makes more sense. If the last header was null, then set the first record position in the linked list to our new position, and then just go ahead and we're going to have to say otherwise. We're going to have to do some weird stuff. We're going to have to say previous header, because remember, our last header is not null at this point. His next record is going to be our new position, because we're patching up the linked list.
Right.
And then we're going to overwrite him with what we just mutated his state to be. And then finally, that's the case if we need to move around a bunch of stuff. You see it's very ugly. Otherwise, all we have to do is write record, existing header, header position, to store item 1, to store item 2. So there we go.
Okay.
Does that make sense? Hopefully. I fumbled it with the names a second ago.
I mean, I know what this thing needs to do, because the bottom line is the record that we're about to overwrite, if it's larger than the space that we're occupying currently inside the data store, then we're going to need to put it at the end. And then putting it to the end means we're going to need to update our next record information so that we can get to it properly. And otherwise, we can just write that information right there where it is currently in the data store.
Right, and not have to do any nasty
exactly
things.
To try to save on some defragmentation.
Yep. Okay, so finally we have append record to list, which will be pretty straightforward. There's no special cases for this thing. All we need is a new position, which will be, of course, at the end. Then we need to figure out what we're writing. And I'm going to call this to store to stay consistent. Get record data to store, which is just going to be record info. And then we're going to write out a record with the new position, our to store item 1 and our to store item 2, item 1 being the header, item 2 being the data. And then we're going to say the previous header, or header in this case, last header. Well, let me verify. Last header. Yeah. Our last header is going to have a next record equal to our new position. And then just like we did up here, we're now going to overwrite last header. So yeah, these are our three methods. So I can go ahead and stub out these guys, I guess. ToStore is going to return a tuple of record header and byte array. Write record is just going to accept all that stuff. He's not going to return anything. This is going to be header, and this is going to be data. So we'll take these two guys and bring them down because they're one layer of abstraction below these guys. We'll need an overwrite header method, which resharper is dumb. And then that's about it. So now we have these three methods left for overwrite header, write record, and get data, record data to store. So to reiterate, when we store, we have a few different cases. If there isn't an item in this record linked list, we store a new record, which just adds the record to the end of the list and sets the index is first position to these coordinates, of these coordinates to this new position. We have a case where we need to overwrite an existing header in the middle of the linked list, which we handle by doing this. And then we have the case where we append the record to the end of the list, which basically is just like store, except for in addition to store, we have to update the next record pointer of the last header to our new position.
Okay. Awesome. Well, that's going to wrap this video up, and in the next video we'll come back and we'll get that get record data to store, the write record, and the overwrite header all implemented. So thanks a lot, everyone.